Physics can be applied to almost anything, even playground equipment. It can explain how fast you go, why you spin, how high you go, or even why you fall off of something.
The seesaw is a perfect example of torque, which is force times distance from the pivot. The sum of the torque is also equal to inertia times angular acceleration, which is what makes the seesaw move up and down. With a friend on each side, you can generate enough torque to make it move.
The rotating platform uses rotational momentum to spin around. Angular momentum is inertia times angular speed. Rotational momentum must be conserved, so when rotational inertia increases, the angular speed must decrease. Here, you can see that as we move closer to the center of mass, our inertia decreases, causing us to spin faster. The opposite happens when we lean away from the center and we move slower.
In order to successfully walk across the balance beam, you must keep your center of mass above the balance beam. If your center of mass shifts, you will fall off the beam, but you can always get back on. Just make sure your center of mass stays above your balance point.
The swing is an example of a simple pendulum in motion. The period of the pendulum can be calculated by multiplying 2 pi times the square root of L over G. L is the length of the swing, and G is the forces of gravity. You may think mass affects the period, but only length determines the period of the swing.
As you slide down the slide, you convert potential energy to kinetic. The forces acting on you as you slide are friction and gravity. At the top of the slide, your potential energy equals your mass times gravity times height of the slide, while your kinetic energy equals 1/2 times your mass times your velocity squared.